Hey everybody, this is Eric Dorward with the Spartan Rocketry Club again. And this time we are going to actually figure out how to load one of our rockets up now that they're built so we can fly it. I've chosen one that's slightly different probably than you have, but this one's a larger one. It's easier to see what I'm doing. Now, there's two main things we need to be able to do with this, right? We need to load the motor and we need to make sure that our recovery system works. So if you were to just plug a motor into this thing without doing anything at all, it would fly up, it would arc over, and it would come down. And it would come down fast and nose down, which would be bad. So every rocket has some form of a recovery system. This one in particular is large enough that it has a parachute. Some of them are small enough that a streamer is good enough, regardless. And there's some that are even small enough that nothing happens. They're very light, they're very small. They just go up and come down. And usually the fact that the motor isn't full of gunpowder anymore means that it weighs less and it doesn't come down nose first. So this one, though, does have a parachute. The way that your motor works is obviously this is the business end, fire comes out this end. But when it's done burning, the last thing a motor does is it has an ejection charge in it. The ejection charge blows up. So from the bottom up the tube, and that pressurizes the top and kicks out whatever recovery system you have. It's gunpowder though, so it's hot, and if you don't do anything, it will melt both this rubber band, that's the shock cord, and the parachute. And if you have a melted parachute, it won't work. So you need something to absorb the heat, or at least prevent the very hot bits of still burning gunpowder from getting to your chute. There are two options for this. One of them that the good people at Estes sell is this stuff. It's recovery wadding. It looks like pieces of toilet paper, but you should absolutely not use toilet paper or any other kind of paper for this job. Instead, this stuff has been soaked with flame retardant chemicals of some sort. They go into the tube to absorb the heat. How many you need depends on how wide the aperture of your rocket is, the diameter of the tube, essentially. This one would need somewhere between 6 and 8. And it says in the packaging, provided you actually read the instructions, how many you'd need. This option works great. It does tend to, when you launch it, throw little pieces of paper, charred paper, all over the place. And this is surprisingly expensive stuff. A package of this costs you like $5 if you get it cheap, and will fly, like 20 flights maybe, but you can do better. The alternative is this stuff. This is insulation. It's not the pink stuff, which holding in my bare hands would make me incredibly itchy. It's cellulose insulation. So it's basically, and if you look at some of this stuff, you can tell, like, there's a piece. This was essentially newsprint at some point, but it's been ground up, and it also has been soaked with some kind of flame retardant or absorbent chemical. This stuff we can use and shove in the tube as well. This stuff costs $15 for like a cubic yard of it and will last you essentially the rest of your life. So this is what we're going to use for the most part. It is hard to use this stuff on smaller rockets. So since we have some wadding, we'll use it for small rockets. But for one like this, I would want to use this. How much? Well, you basically want enough so that the parachute is well insulated. So that's probably about good enough. Just kind of a small handful. You probably can't see it in there, but it's in there. Wouldn't hurt to have a little bit extra, I suppose. So you just kind of dump some in, and that will absorb the heat. Then we actually need to deal, and yeah, this stuff makes a mess. More serious rocketeers call this stuff dog barf, probably for a reason, because it's, I don't know why they call it that, but they do. In any event, once we've got our protection in there, be it wadding or be it dog barf, we need to do something with the parachute. We want to make sure the parachute is as untangled as it can possibly be. So I'm just going to kind of unspin it here because it's a little tangled. Then we're going to start folding it. Now, there are professionals who do this kind of competitive stuff and they really care about how your chute is packaged, because how long it takes to deploy makes a huge difference for them. For us, we just want it to deploy, and we want to be able to get it in the tube. So the first thing we're going to do is we're going to fold it in half, and we're going to try to get the reinforcement rings lined up with each other, but not right on our fold. So like this. Then we're just going to fold it in half a bunch of times. So it's in quarters, eighths, and so on. You don't really want me counting all this, but we want it to be about this size. Again, there are ways to package this to make it neat and deploy really quickly, but again, we're just looking to get a deployment at all. So once it's about this narrow, what we're going to do is we're going to either fold it in half if it's a small one. This one's big enough, though, that we can probably try a Z fold. So we're going to fold it basically in thirds so that it makes a Z. Kind of, once you've done that, you can probably kind of like round it up. And again, if you were an expert, you would have the shroud lines inside here, but we're just going to wrap them around the outside to kind of hold things together. There we go. Once this is all wrapped up, we're going to shove it in the tube. We're going to make sure the shock cord is all in the tube as well. And if you're working on a smaller rocket, this tends to be a royal pain. Even right now, it's kind of fighting me. This is a big old elastic line. It doesn't really like being squeezed up. So anyway, there we go. It's all buttoned up. Now the motor. So we need the business end of the rocket. If you have not used a motor before, they are all printed with letters. The first letter tells you how powerful the engine is, essentially. This is an A. It's the smallest regular 18 millimeter motor that we have. They do make half A's, but this is the smallest we're going to use. The second number essentially tells you the maximum thrust that the rocket puts out. For a gunpowder motor like this, it's somewhere between 4 and I've seen up to 12 in larger ones, but yeah. It essentially tells you how loud the rocket is going to be, is my experience. And the last number, the 13, tells you how long it's going to take from the rocket to stop burning its fuel to when it kicks off the ejection charge. So when you light this, it'll burn, fire comes out this end, pushes the rocket forward. It only lasts so long. This one lasts something like a quarter of a second. For the next 2 seconds and 2.75 seconds, it's going to be coasting, but it's going to be putting out smoke. That makes it easier to track. After 3 total seconds, though, the ejection charge is going to pop, and that's what this last number tells us. Anyway, so this goes in. In this rocket, we've got a hook to hold it in place. You may not. You may have to tape it in place, whatever you've got. Goes in snugly like that. Of course, we use electronic ignition, and that requires an igniter like these. So let's open the pack. This is a brand new pack. These things are admittedly finicky. The electricity from our igniter, or from our launch system, goes up in here and makes this part hot. This one actually is a new kind, I think. Originally, they had basically a little bit of, not gunpowder, but something similar here that would get very hot and actually like catch fire and then set the motor. These ones look like they're using a more modern release, but it doesn't matter. We only need one. These things have a penchant for shorting out. We need the electricity to go the whole way to the tip and then back before they actually like touch. Here's kind of like a bottleneck. We could get a short right in here. So I'm going to be very careful and kind of push these apart a little bit without messing up the end too much. Spread it out a little bit. Now, this goes in here. It's not going to stay just like that, so we need one of these plugs. They are specific to the throat size of the motor. So these all have a little tag that says A8, and they go in there. I'm not going to actually pop one off because I don't want to lose it. But in any event, this goes in, and then the little engine mount, motor retainer goes in there as well. Motor retainer is not the word. It's a plug. It's an engine plug. It goes in there. That'll hold this in place. You can then fold it over, it won't move, and then you can connect the clips from the ignition system, one to each of these wires. Now, of course, we don't fully load a rocket indoors under normal circumstances. So this is not hooked up to anything. You would only load the motor part outside for safety's sake. Loading the parachute, yeah, you can do that inside, but don't do it too early because you don't want things to get settled, and that kind of thing. We want the parachute to be as freshly packed as possible. Once that's all set, you can take your rocket out to the pad, load it up, and hopefully you'll have a good flight. Thanks for watching. I'll talk to you again another time.